Hi, I'm Lars. Welcome back to the shop. Just put out a video on the F1 setup for the Masso G3 version 5.03. Got a couple comments. People liked it. And this video is going to be about the F3, F4, F6, and F2 screens on the Masso G3. If you're interested in this, stick around. Please like the video and please subscribe to the channel if you haven't already. So let's get to it. All right, now for the meat and potatoes. This video has been pretty hard for me to get together, all right? Because explaining how to probe is not the easiest thing in the world. And when I go through the probe screen, you're going to see what I mean. But these screens, the F3, 4, 6, and 2, let's take out the 4 because it's not right there, but the F2, 3, and 6 are all the same screen. They just have a different zone on it, okay? So if you look at the screen right here, there's a little area here at the bottom, and it's the bottom right-hand side where my hand is, all right? For the F3, it looks one way, for the F2, it looks another way, and for the F6, it looks this way, all right? Everything else on these screens are the same. So with that in mind, if you're just getting into CNC programming and stuff and running this CNC machine, we've already done the F1 setup, has a bunch of tabs. That there you can go in and it'll help you with your settings. But learning how the F2, F3, and F6 work is so much easier when you realize that there's only 3 little areas here that you need to really learn about. I'm going to hit this F5 conversational, which I don't have any idea why it's named that, but anyway, let's get into this one here for just a minute. This is a conversational F5 tab, all right, the screen. I am never in here. I don't know what a wizard file name is. Maybe you can put a wizard in here. I know you can do an add a wizard or select a wizard, add edit, so face cut, profile cut, rectangle pocket, and circular pocket. I don't know what happens if you select one. So then you got to put your start places and stuff maybe. I don't know. So I'm just going to cancel out of this and tell you guys I'm sorry, but I don't really know much about this. I don't know many people who do. So if somebody does have this, please put it down in the comments. If you got a video on it, feel free to put it in there. And we can share that information around. So this video is going to be about the F2, F3, and F6, F4, and F6 tabs. F2, F3, and F6 all have unique zones right here. For F6, this is where you load your files. F3, you do your probing. You can do your jogging here, and you can do your probing. We'll get into that in a minute. And then F2 is for your program, you're running your programs and entering MDI code. And exit out of that. But first thing we need to do is we need to hit the E-stop button and then home the machine. First thing I do when I get in, because this is usually setting here, I do the homing of the machine and I zero out my machine's coordinates. And I'm going to be very thorough about this is your machine's coordinates. This is not your work origin. This screen allows you to set up your work origin. Now, let's just go through this area here. Most people will run this in continuous mode for most of the work that they're doing. The feed rate and continuous mode are connected to each other. I don't know why you're in step mode that this even moves. If this was my design, I would have gotten rid of this entirely. I think it adds confusion. So continuous mode, you can move your spindle. So I'm just going to put this out here and just kind of show you guys what it does. There we go. So if you go X plus, it goes like this, X minus, Y plus, Y minus, and then you can do Z minus and Z plus. So plus for Z is up, minus for Z is down, X goes to the right, Y goes away from you. For positive, X minus goes to the left, and Y comes to you for negative. Okay, now if you want to know how to flip this all around and go another direction, everything on mine is inverted. That's how it normally comes. But if you wanted X to come towards you, or rather Y to come towards you, and X go to the left, or just Y to come towards you and X go to the right, you can uninvert them, all right? And that's over in setup 1. But I'm not going to get into that because that'll take me down a rabbit hole. Okay, second thing on this screen is this. Is step mode. So if we're gonna work with just the Z height here, and I'm going to move this. Well, put this on continuous. I'm going to bring us back over here so you guys can see both of these things. Z is as high up as it can go. We're going to go to step mode. And I'll tilt this down a little bit so you can actually see it move. Well, you should be able to see it move here. If we're on 0.1, that means right now we're at Z0. That's as high up as it can go. Remember, Z travels in negative numbers. So if I hit this Z minus, this is going to go to minus 0.1. The numbers out to the edge, again, this is woodworking. If you're doing this for metal, it's still going to be negative 1.04. It's not that precise of a machine, okay? If I hit it again and the 0.1, they go to minus 0.2, minus 0.3, minus 0.4. If I switch this over to the, I believe this is the hundreds position, it's going to be subtracting or adding, it's going to be subtracting a 0.01 every time. So you see it goes 2, 3, 4, 5. If I put this over one more to the thousandths, you can barely see the spindle moving. You probably can't even hear it anymore. But you see how that number keeps on moving? The last number out here is the 10 thousandths or 5 thousandths, because it's 0.005. When I do that, I've never had this do anything different than this 0.001, the 1,000ths mark. Okay. There you go. So that's how step mode works in continuous mode. Continuous mode, the speed rate, be very careful with this on Z axis or any of the axes, because if you are at 33, it's not moving that fast, right? When you're up here, that thing moves really quick at 100%, or if you're down here, it's going to be really slow. So when you're probing stuff, I would slow this down going down on the Z. Otherwise, you could bury your bit, you could snap a bit, there's a variety of things that could happen. So I'm going to bring this back up, and remember, this is the machine coordinates. They should match right here. So this is kind of funky right now because my Y, okay, so you see the 0.5, 0.25. Remember, in my setup, my home position is 0.5 on the Y and 0.25 on the X. Just making that clear, and I'm going to zero everything back out. Alright, we can even double click on this to home it. Now it's all truly zeroed out. So, one rule I have is when you're running a piece of code, when you're going to run G code, only home one time. Because you saw what happened when I moved this out here and did a bunch of stuff, and I came back and I rehomed, we were in negative numbers. Alright? If you didn't see that, rewind the video just a little bit. Now, so the hardest thing that I had a problem doing when I was putting this video together is explaining how this probing screen works. And the reason is there's actually 3 functions on this probing screen. And I'm going to do my best to explain this, but it is one of those things that either you're gonna get it, you're gonna understand it, or you're not. So I'll go, like I said, I'm going to try to do the best job I can at this. All right. So let's start by talking about what a circuit is. In order to probe, you need to complete a circuit. And the way you complete a circuit is with this thing. One side has a magnet Everybody that has this knows what this is, okay? You stick it on your collet, all right? This thing here you put on your stock, and you bring a bit up to touch this, and when it touches it backs off, and then you get a reading for either X, Y, or Z. Very easy. What you might not know, which I got this information from Terrapin Creations. If you haven't seen his stuff, go out to Terrapin Creations on YouTube. Guy makes amazing things. His name is Bill Tracy or William Tracy. You see him on Facebook in our group all the time. He really knows stuff about cutting PVC signs, using templating. He does a lot of really cool crosses and stuff like that. All right, Celtic crosses. Really got to check out his stuff. But this is what I learned from him. If you have a spindle, all right, go find a piece of metal and stick that magnet on it. Then you don't have to keep on putting it on your probe. You're not going to forget about it anymore. Now here's something that I don't know if you guys know about or not, but I do, so I'm going to share it. On your screen, the very top, you see probe and workset offset G54. Now, the workset offset is where the probe data is going to be saved, in what offset, which is over here, okay? Down here. I'm going to back this out a little bit. So that's the G54. It's named work origin, and this is where the current values are because we home the machine. Ignore all that right now because we're going to actually put something in here. So if we go back to the probing, the way you pick which offset you want, you got G54, G55, and I don't know if you can see this changing up here, but there it says G55 now, it says G56, 57, 58, 59. Now, leave this on G54 unless you're going to change your software, because your software has an offset set up for G54. And if you don't, and you put it on G55, this is going to be your offset right here. When your code executes, which I'll show you that when we get to the code portion, there will be a G54 setting there. It won't be G55 unless you change it in your software. So if it says G54 in your code, you're going to read this, you're going to throw a soft limit, and you're going to be like, I don't know why I'm throwing a soft limit. That's the reason. Alright, so make sure this says G54 at the top if your code is throwing G54. Now, something that I don't know if everybody knows, I do, so I'm going to share. Watch this little thing that says probe. See it turn green? It's no green. Now it is green. All I'm doing to make that happen is touching this to the bit. Alright? So, if you're having a problem with your probe, you're not getting probes right, it's crashing all the time or whatever, that's a way to test your probe system to see if that baby turns green. Alright, just friendly knowledge, just hoping everybody now knows that. Alright, the probing screen is made up of two different parts. One is the settings. Now, the probe diameter, I'll get to the inside out in a minute. The probe diameter is the diameter of the bit that you're going to probe with. Now, you can't probe with a V-bit, because unless you're using the top of the V-bit or flipping upside down or whatever. So you can't probe with a V-bit. It's better to probe with a flat end mill instead of a ball nose, and then you can get your probe diameter. There are some people out there that what they'll probe with, this is not a broken bit, but if it was a broken bit, like say it was snapped off here, they will put this, they will either cut this off and put it up into the collet, and they'll probe off of that. They'll use this to probe off of every time. It's, you know, they'll measure it, make sure it's the right, whatever diameter you want. This is a 1/4 inch bit. But so that if this was truly 1/4 inch, I'd put in 0.25, and I would always put this in and probe. Now, not all of us do that. You know, I'm going to be cutting something with a 1/8 inch bit, so I've got a 1/8 inch bit in there. Probing feed rate. How fast do you want it to probe? I'm keeping mine at 10. I don't really need it to be running any faster. I don't want to snap a bit in case something happens, so I'll just leave it at 10. Your X offset, Y offset, and Z offset. And to explain these guys, one needs to understand how the coordinate systems work on a machine. So let's take this as being your wasteboard, and your machine coordinates for 0, 0, 0 are always this point here. Now, you could have homed your machine like I did and said, I want my machine to be off a little bit, but these are still based on these machine coordinates. If you look at the screen where the yellow box is, you can see that the machine has been homed. The red box signifies the location of the machine, the actual location of the spindle. Now, this is very important to understand. When you put a piece of stock down on the board, on your waste board, when we try to pick up this corner here, all right, so here's the probe block that's going to be dropped down. So when we put the probe block on, and this little dot here represents how it sets up on the little lower left corner, your spindle bit comes down and taps on this side, comes up, comes over, comes back down, and taps on this side. At that point in time, you have found the probe location. And I'm just going to put this in saying it's 4 and 4, just for easy math, is this point right here. And that's what the probe has found. All right? Now, I know you're looking at this saying, no, we're finding this down here. Well, there is a truth to that, but the thing is the computer, or the G3, subtracts whatever offset you have for X and offset for Y, and correlates that back to the work origin. And then you end up with the work origin here of this point, which is the front corner of this piece of stock. This is a very important concept because not all three, and I have to say, this is very important about how the probe works. The reason I'm saying that is there is 3 probing functions on the probe screen. They all work exactly the same. And on the third one, when you're finding the center of a block from the edges, like that, if you put an offset in here, then your center is going to end up over here in the corner somewhere. Because as soon as you find the center, it's going to say, apply the offset. And it will go to the top right because it's going to add the offsets. They subtract the offsets from this point. So we end up with this corner here. If you're up here, it's going to subtract one, it's going to add the other. If you're up here, it's going to add them both. If it's down here, it's going to add one and subtract the other. Okay? So this concept needs to be understood in order for you to understand how probing works. And I hope this helped. I'm really hoping that information on the coordinate system helped. So let's try to get that to be applied to the actual physical machine. So we're talking about X offset, Y offset, and the Z offset I'm going to leave off for a minute. But the X offset and Y offset, this probe block, this block here for the outside is referring to this probe block. Now when we put this probe block on stock, it's going to set on a piece of stock like this. So where that circle is, you're going to press that top corner. If you were to turn this and put it on this side, you would press this corner. And the same as it goes all the way around. Alright, so wherever that circle is where you put the block on, that's the corner you're going to press. Pretty easy to understand. Now, the X offset, Y offset. For me, I work on the front left corner of the stock. So this is the way my probe would set. And I will turn it this way, and then we will need to measure from here to here for the X, and from here to the Y. Now the way you do this is you use a caliper. And this is what a caliper is. Alright? If you don't have one of these, you need to buy one. So when you turn it on, make sure you zero it out, make sure it's everything to 0. If it's not zeroed out, then hit the 0 button. And then you've got this little stick here on the end. Hopefully you can see that. That comes out to the edge. If you turn this over and flip it over like this, okay, you push that stick all the way in until it hits the other side. So I'm going to turn this down like this, but like that. So it's hitting the other side, and then you push your caliper up to the very edge. That allows you to read the numbers that you have. Okay? Now it might take you a little bit of time to play around with it if you haven't done this before, but that's how you find your X and your Y. So for me, I'm doing the bottom right corner. So I'll turn it this way and measure from here to here, and my Y will go from here to here. So X and Y. This is the Z thickness. So those are your offsets. Let's try to relate what I did in Visio on here in real life. So if you remember from the Visio diagram, I'm going to move some of this stuff out of the way. This point right here is the origin. Okay, right where this little bit holder is with the little blue top. I'm going to turn it upside down so you guys can see it really well. That's where the origin at. That corner right here is 0, 0, 0 for the entire machine. The home for me, for my machine, my home is right about here. Okay, and I do this because I've got screws that are sitting on the edge of my spoil board. Over here on the right a little bit, this is the piece of wood that we're trying to find this point right here, this one right here, this little point. So we put our block on it. I usually line up with the right side of the mill, and I'm probably pretty much everybody else does too. And the reason for that is because it's about an inch off the side. And I try to get it as pretty close as I can. So now we have this lined up, I'm going to run this probe. So I'm hitting this top right button here, because remember I'm hitting the button where the 0 is on the probe. Now this just picked up the Y plane along the side of this. And the reason I'm saying it's a plane, think about it as there is literally a piece of paper sticking up on this side, and there's one on this side. So what we actually picked up, as far as the probe software is concerned, we picked up where this plane here intersects this plane, or better yet, it's this corner right here. Now the offset that we put in from measuring the back of this just got subtracted because we're in the bottom left quadrant, okay, or quadrant 3. We subtracted both the X and Y offset. If we would have been in the top right quadrant over here, we would have added them. If we would have been in this quadrant, like this, okay, we would have added the Y and subtracted the X. If we would have been down in this far quadrant number 4, or front right, we would have added the X and subtracted the Y. So kind of keep that in mind. You just need to understand if you're using this one here, you're subtracting both, and then as you go around they change. Seriously sit down and think about that, because that's going to help you a lot with actually understanding probing when we get to the next two functions. Now, we're kind of staying away from the Z at the moment, but we need to do that for this one. So this block is 0.59 inches thick, and that's going to be the offset. So it doesn't matter if I lay this block on here like this, or if I flip it over, it's the same thickness. And to pick up the Z offset, you need to hit this button in the middle. So I'm going to press the middle button. Now, what this did is this picked up the plane that is at the same height as the top of this block. So right here. Then, due to the software and the function of it, it subtracted the 0.59 and brought it down to this level. So now we have Z at this level right here for the work origin. We have X and Y. On this side is the X, this side's the Y where they cross, and Z is here. So the point, this little tiny point here on the corner, is actually 0, 0, 0. So this is where a little bit of magic happens. If you go back to program MDI, let me get out of probing, and we hit go to work origin. you'll see that X and Y are not exactly 0, 0. Now, I am a little anal retentive. I like to see when I'm moving along so that I don't have to subtract, add 3 to it and then subtract 1. So I just zero out X and Y. I could zero out Z if we brought this bit all the way down to here. Because right now it's at the machine's Z level of 0. This is the machine's 0 coordinate. This is the work origin 0 coordinate. This here is the work origin's X and Y 0 coordinates because it's right above this point. So again, X and Y are at 0 work origin. The Z based on the work origin, so take this guy here as being the work origin now, is 4.6205 inches above the Z's work origin. Now, regardless of all of that, your machine is telling you that your X is at 19.3197, your Y is at 1.365, and your Z is at 0. Okay? Now, why is the work origin so important? And I'm going to pop over here to offset, and you're going to see that down here that this is the work origin is based on the machine. All right, same exact numbers. Now you see this is negative 6.2051. It's the opposite of that. It's the negative of that because we need to go down to negative 6.2051 according to the work offset in order for these all to be 0. The main thing to understand is that the work origin is what your program is going to base all of its movements on. So keeping the X and Y zeroed out, leaving Z alone is very important. If you're still having problems with this or don't understand it, drop a note into the comment and I will see if I can explain this in better detail. So this next part is about doing inside probes. Probes that are going to be the inner corner or finding the center of something that has a pocket. Alright, going to try to do these the best I can. I think these are mainly made for people that are using this mill or using the Masso G3 to do milling with that's on something using metal that you can just take your probe and set it on it and then tap off the sides with the bit, because that will transfer the circuit, the current and everything through the metal and all the way back to the Masso. Honestly, I do not know, but I did find a way with a little assistance from my wife to show how these work. Okay, but you do need metal. So, if you remember from the first probe function, we had put this on here and we measured across from here to here and from here to here. Now for this one, we're going to set this on the inside here like that. I do believe that a lot of these things are set up for shops that are using metal and not for wood, but if you have something like this, you could do this too. You could pick up this inside corner with this. As long as you can get this in here, your probe connector here can lay flat enough because you don't want it sitting up like this or like that or whatever. So if you can get this in here pretty flat or shim it up or something, you could do this. Now, the difference between this is we're trying to find this corner right here, this guy right here. And when we probe this, we're going to actually find this as being our probe location, because we're going to probe against this wall and this wall, and we're going to hit that. So we need to subtract this wall for the Y and this wall for the X to get to here. So what that means is we need to take out our calipers again, and we need to find out what this side is and this side. Okay. Now, make sure if you do this and you're trying this out, you need to make sure this is your X offset right here. You need to make sure this is your X offset and this measurement is your Y offset. So I'm going to enter these in for I've already got mine done, so I'm just going to enter them in. So these are my measurements for my X offset, and then I'm going to hit Save Settings. Now, notice there was no change here. So I forgot to hit the inside out. I really wish this button would either stay engaged if it was inside or opposite for out. I don't care. And then we're going to hit save settings. Now you're going to see this change. So this box is different from the outside. So inside, you can say you're all on inside. So now wherever this circle is, and no, these are not here for that, I'm just giving you a reference. This circle is the box that you want to press. So for us, we're using that front left corner, so we're going to press that one. Alright, we're off that, and now I'm just going to press that button. I'm going to raise this up a little bit and back it out. Remember, we're looking for where this point is right here. So I'm going to hit work, go back to programming MDI, and hit go to work origin. This will come up and it'll come over to here. I'm going to zero out my X and Y just like I normally do. And 0 is still 4.62 because it's where the Z0 is. But for this one here, we're going to lower it down just to make sure that it's where we think it should be. So right there, we're on the edge of the X side coming, and we're lined up with that. So that is the new work origin for that inside corner. Alright, so for this next function, we want to find the center of this rectangle, which should be right about here. In order to do this, we're going to use a probing block like this. And we're just going to tap on the side of the probing block with the bit, okay? The way this function works is the bit will come down and it will run this direction, negative X, then it will go positive X, then it'll go negative Y, then it'll go positive Y. So I'm going to have to take this and move this around like this, from this, you know, from this side to this side, down to the bottom, and then I'm going to have to throw it up to the top. And this will find the center of that rectangle. Something to keep in mind is how the probe works. The way the probe works is it finds the probe location first, and then it applies the offsets. This is why I've got X offset set to 0 and Y offset set to 0. We're going to go on an inside probe, and I'm going to reduce the probing feed rate to 5 because I don't know how fast my hands can move to get this thing around here, and I don't want to snap a bit. Alright, now I'm going to hit that yellow button. That is going to be the 0 position, the center of that box. So I'm going to go back to programming MDI and hit to go to work origin and raise it up. Notice it didn't move anywhere, didn't go anywhere. That is the center of the rectangle. So that's all 3 functions of probing. I hope that made sense. If not, throw something in the comments. I'll be more than happy to try to clarify this or make a short or something, maybe a shorter video of this to help you out. Clicking the button for the very last function from inside to outside does not matter. I've already tested it out. Didn't want to show that to keep the video short. So on to the next. Okay, from here we're going to go to the F6 for load file. This is probably the simplest of the F2, F3, and F6 zones that we have. This works a lot like Windows or Macintosh or whatever tool you're using. I'm going to go down here to lanterns for jigs. If I can get it open. Bells. I'm just going to load up some bells. Nothing major. Just going to hit the load button down here. I could have also double clicked it. Now at this point, you can hit cancel to stop the preview, but I don't think anyone really ever does that. Maybe if it's a really intense preview or something like that. From this point, you can go in and edit. I highly do not recommend this unless you're just going in to change like a tool number or something like that. So if you go page down, you'll see there is the M06T3, which tells you the tool change to tool number 3, which just brings me to one thing I need to talk about. So in tool 3, this is a 1/8 inch end mill. So we're going to go to tools and offsets real quick. These tool numbers here, I've got set up for, here's my tool 3, 1/8 inch end mill. I got it tool diameter 0.125. These tools must match your software. So your tool number 3 here for 1/8 inch needs to match whatever's in your software. If not, you're going to have a lot of problems. Let's go back to load file. G17, this guy sets up the XY plane. G90 sets everything to absolute. G94 sets your units, you know, inches if you will. G54, that's where your offset comes in. Remember I was going to tell you about that. That's the work offset that you're going to use. If that's the G55, when it gets down to this piece of code up here at work offset, it would be G55. Your G00 means go as fast as you can to that point. If you have never read G code or M code, it's very interesting to figure out how they do things. And most of the stuff they do today is dealing with splines. You don't really do circles and squares and stuff like that. But I'll put some links in the description of websites where you guys can go and you can learn about this stuff a little better. Okay. So on this side here, so we've already talked about jogging, probing, tool offsets, conversational, and load file. Let's look at program and MDI. Like I said, I'm not going to run any code here. We've already talked about spindle CW doesn't do anything. Spindle CW turns your spindle going forward. None of these buttons here are any different than running G code. So your spindle CW be an M03, then you put an S for the speeds for 1000 or 1600 or whatever. Single block will execute one line of code at a time. So every time that it executes a line, it's setting on it. So the one that it's executing now is G90. That's just executed it. G94, G17, on and on and on. Like this one here is going to say, here's my new tool change. G17 again. And then we're going to go down to G2.0, Z.0. So that's why that dropped. Alright? It dropped a considerable amount. The next one's going to put it at the work origin, which is 00. And then this one here is going to move it out into the field. I'm just going to show you what it does when it moves. So I just threw it across there. The next one will lower it down to, well, I'm not going to lower it down, but you get the idea of how this works. I'm going to rewind this back. Control start or cycle start or Control S will, if you have your keyboard hooked up, it will execute either a single block if that's turned on or the entire thing. This green button does the same thing. This is your feed hold escape. Here's your feed hold, or you can hit escape on your keyboard. That will stop it. Everything will hold out where it is. If the spindle's spinning, it'll stop. At that point you can go back here, you can raise it up, and then you can turn the spindle off. Rewind, you know, brings you back to the beginning. Alright, so MDI, this button down here, Control M, in case you want to run an MDI command. Like if you wanted to say M03 S say 1000 and then hit run. Well, looky there. See my spindle's spinning now? So that's moving. If I wanted to stop it, I could come back over here and hit spindle stop and it will stop. These are just running M codes, alright? One M code that everybody's probably really curious about is how do you change the time? And that there takes a capital T, I-M-E, and then colon, help if I hit M, right? M-E, colon, and it's 6:38 p.m. here, so I'm just going to say 06, or sorry. It's in military time, so to be 18:37, and then hit run. And that changed that to 6:37. Alright? So that's some MDI things. You guys can play around with that. Dry run's pretty cool. If you were running a dry run, notice this lights up here. It means that the spindle will not start up and your Z will not engage. So if the Z says go down or up or whatever, it'll just stay where it's at, up at the origin of it. Not the work origin, the actual origin. Because it was at the work origin, it would just drag across your product, and that's not good. So let's get out of that. Alright, so I hope that this video answered a lot of questions or informed you about stuff that you didn't know before. I think it makes sense that, you know, they left F2, F3, and F6 to be pretty much the same screen, and that they're just changing out the Z, you know, that little zone in there. If you like the video, please click like. If you have anything that you want to talk about in the comments or any more questions, if you want me to get more detail about a specific screen or function, let me know. Okay, I don't mind doing these videos for everybody. I kind of feel like it's kind of like a library for people to go back and revisit, and for myself to even go back and revisit. Please subscribe to the channel. You guys are always welcome back in the shop, and as always, have a nice day.